Basically what this question is asking you to do is it's asking you to apply real-world concepts to things that we already know, like, for example, the vertex, the x and y intercepts, and the axis of symmetry. So what does this point right here represent in the problem with the soccer ball? It represents the starting point of the ball before it was kicked. So at the point where before it was kicked, it's at 0 time, and it's on the ground, so it's at 0 feet. The ball travels up over a few seconds, so till it gets to the vertex where it's at its highest point. What is the height of the ball at that point? The height of the ball at that point is the y value of the vertex, so it's at 69.8625 feet. That was given to you. And how many seconds is that? That occurred at 2.8125 seconds. That was also given to you. Okay. And then the ball continued to travel until it hit the ground. Did it go underneath the ground? Did it go through the ground? No. So when we're talking about real life problems, it's not going to go down to infinity. It's going to stop here at 0. Why? Because that's where the ground is, and the ball's not a bomb. And where does that occur? Well, it occurs at 0 feet, because again, it's back on the ground, and that occurs at 5.625 seconds. So you should be able to answer the questions based on that kind of analysis of the graph and going through here. Now, one of the things that I did is I made a mistake. Is the domain actually negative infinity to positive infinity on this? No, because it started here when the ball was kicked at 0, and it ended here when the ball hit the ground at 5.625 seconds. As far as the range is concerned, did it start underground and then go all the way up? No. Again, we're talking about real life here. It started at 0, and it ended when the ball hit the ground at 5.625 seconds, but it ended at a height of 69.8625 feet. All right, I'm going to go ahead and leave you with that. If you have any more questions, go ahead and ask. Talk to you soon.